Good morning, all of you. Today we will perform the experiment 6, and in the experiment 6 we will implement the sampling theory. The objective of the experiment is to observe the operation and the different sampling and reconstruction of baseband signal and examine the effect of the aliasing by using the Emona Telecoms-Trainer kit. So these are the apparatus required to perform the experiment. In general, a typical time dependent signal, for example, the AC voltage, is a continuous with respect to the magnitude and time. Such signal are called the analog signal. Using a normal oscilloscope, we can get a analog representation of such a signal. Today, mainly digital equipment is used for the electrical measurement. Originally, the analog signal is converted to the digital signal. A digital signal is discrete with respect to the magnitude as well as time. Therefore, conversion of an analog to a digital signal means the value of the analog signal function is measured in the discrete time. Sampling is the process to convert a analog signal to a discrete signal, and the corresponding sequence of samples that are usually spaced uniformly in time. The process discrete time signal is usually converted back to the analog form by interpolation, resulting in a reconstruction analog signal. The sample reads the value of the analog signal GT at equally spaced sampling instant, and the time interval Ts between the adjacent sample is known as the sampling period or sampling interval. The sampling rate measured in samples per second, and which is equal to 1 by Ts. There are two statements about the sampling theory. The first statement states that signal should be a band limited with the finite energy, which has a no frequency component higher than the f of m hertz, is completely described by specific the value of signal at instant of time separated by 1 by 2 fm seconds. The second statement states that the band limited signal, which has no frequency component higher than f of m hertz, must be completely recovered from the knowledge of its samples by taking at the rate of or more than 2 fm per second. That condition is called the Nyquist criteria. If the sampling frequency is less than the Nyquist rate, then there is a distortion which is called as a aliasing. We can divide the sampling techniques into two categories. One is called the natural sampling and second is the flat top sampling. Natural sampling is similar to the impulse sampling, except the impulse train is replaced by the pulse train of period t. We multiply the input signal GT with the pulse train as shown below over here, and we will get the natural sample. So these are the block diagram for a natural sampling. During the transmission, noise is introduced at the top of the transmission pulse, which can be easily removed if the pulse is in the form of flat top. Here the top of the samples are flat, that is, they have constant amplitude. Hence it is called the flat top sampling or practical sampling. Or we can get the flat top sample by using the sample and hold circuit. This is the block diagram for reconstructing the sampled masses. This is the block diagram for study the aliasing effect. This is the circuit diagram for the natural sampling using Emona Telecoms-Trainer kits. So this is the circuit diagram for get the flat top samples by using the sample and hold scheme. This is the connection diagram for sampled a piece signal. This is the connection diagram for reconstructing the message signal from the samples. This is the connection diagram for studying the effect of aliasing. These are the some precaution is required to perform the experiment. These are the few steps which is required to perform natural sampling. These are the few steps which is required for getting the flat top samples by using sample and hold circuit. This is the some steps is required to get the samples for speech signal. This is the few steps to reconstruct the signal from the sampled masses. These are the steps which is required to observe the aliasing effect. This is the graph for the natural sampling. This is the graph for the flat top sampling. This is the graph for the speech signal. This is the graph for the reconstructing the original signal or original message signal from the sampled value, and this is the graph for observing the aliasing effect.
So our next experiment is to observe the operation of different sampling and reconstruction techniques on baseband signal and examine the effect of aliasing by using Emona Telecoms-Trainer kit. Okay, so you see uh, this is the block diagram for the sampling of a message signal. Okay, using this is natural samplings. Okay, and this is the connection diagram for your natural sampling. This is your for sampling using sample and hold circuit. These are the connection diagrams. This is the block diagram for sampling using sample and hold circuit. This is of sampling of a speech. This is reconstructing a sampled message. This is the block diagram for reconstructing. And this last one is, this is your aliasing, to study the effect of aliasing, connection diagram and as well as block diagrams. So these are the diagrams. So we will implement it in the trainer kit. So you see in the block diagram, this is your message sampling signal and sampled message. This is for natural sampling, this is for sample and hold circuit. Okay, so we'll start connect as according to the diagram. First give a 2 kilohertz signal, sinusoidal signal from master signal to your dual analog switch. This input. Okay, 8 kilohertz to, okay, we'll see. Ground. So this is our channel 1. We'll see the message signal. Output. So adjust this horizontal time base positions. You see, this is your input signal, this is your sampled signals, natural sampling. Okay, so second part is we will use sample and hold circuit to do sampling. Okay, So this is your sample and hold circuit. You give this signal to, okay, and this is your input signals 2 kilohertz. You will give to sample and hold in. Okay, sample and hold in, and the output will see through sample and hold output. Okay, so this is from sampling using sample and hold circuit. You see in the beginning, this is your sample and hold circuit. This is natural sampling. Okay, so next is sampling of speech, third part. This is the connection diagram. So instead of this input signal of 2 kilohertz, we will give a speech input, and remaining is same. And this is input, sample and input speech. Okay, so try to make some sound while watching the DSO. You see my voice, how it appears in see, while watching the DSO you have to make some sound, then only you can visualize. You see, okay, so in this way, while making some noise or some sound, you will see the output of sample and hold circuit sampling. Okay, so our next part is how to recover a sampled signal. So this is the connection diagram for the reconstructing a sampled message. So you give the input of 2 kilohertz to sample and input. So 8 kilohertz sample and output. It will be connected to tunable low pass filter input. Then the output of a tunable low pass filter we'll see through channel 2. This is okay, so connection is done. You see the output. This is the reconstructed part. I am increasing the gain, that's why it is increasing. Adjust, this is the cutoff frequency. Adjust control FC, you adjust little bit. Okay, so this is your output reconstructed sample signals. Okay, so in this way, then the next part is to observe the effect of aliasing. To observe the effect of aliasing, this is the block diagram and this is your connection diagram. Okay, so connect accordingly. So 2 kilohertz to sample and hold input. So from BDC, from VCO digital to control. Okay, so the output of this sample and hold output is connected to tunable low pass filter input. This output okay. Set the VCO modules, adjust control to low positions, okay, and adjust VCO modules frequency in such a way that the reconstructed adjusting to so that no longer distorted. Okay, You measure the signal's period and frequency, VCO module's digital output. This is the VCO module's digital output we are given to control. So you measure first frequency, okay. So this is the end of the experiment.